in listen-only mode.
Good morning and good afternoon. We'll be starting our webinar shortly. Participants are still streaming in, so we'll give ourselves another couple of minutes and we'll start. Rob?
Yes.
You can hear me. Okay, good. I will start.
I can hear you. Yep.
Welcome to today's presentation. Lee, TD Williamson, Asia Pacific, the Middle East. Before we begin, I would like you to know that this webinar is for internal references. Question and answer session at the end. Submit questions anytime. We will show you how on the next slide. At the end of this webinar will be a survey. Please be sure to give us some feedback so we know how we are doing. As you can see on the screen, this is the control panel. You will see something that looks like this on your own computer desktop in the upper right corner. You are listening in using your computer's speaker system by default. If you would prefer to join over the phone, just select phone call in the audio pane and the dial-in information will be displayed. The control panel will collapse automatically when not in use. Simply click the orange arrow to expand again. Please note that attendees are automatically on mute. Next, you will have the opportunity to submit text questions to today's presenter by typing into the questions pane of the control panel. You may send in your questions at any time. We will collect these and address them during the Q&A session at the end of the presentation. If we don't get to your question, please be sure to post in the survey for follow-up after the presentation. You may also see an icon to raise your hand. We have disabled this feature for our presentation and ask that you use the questions pane instead. I would now like to introduce today's featured speakers. Rolf Gunali, Senior Technical Consultant, is based here in Singapore. Rolf Gunnar is from Norway and has a mechanical engineering degree from Glasgow University. Rolf Gunnar has more than 20 years experience from the oil and gas industry and been with TDW since 2005 in Norway, Houston, and Singapore. Rolf Gunnar has vast experiences in manufacturing, engineering, project management, and regional sales, and has spent the last decade in developing the inline isolation smart plug business for TDW. He is joined by Gary Anderson, Offshore Market Development Director from our office in the UK. Gary is a chartered engineer with the Institute of Mechanical Engineers. He has 30 years experience in the pipeline integrity business, where he has held roles in field engineering, project management, operations management, and business and technology development for companies including British Gas, GE, Secor, Baker Hughes, and TD Williamson. For the past 9 years, he has been involved with inline isolation smart plug. With that, I'm going to hand over the presentation to Rolf Gunnar.
Thank you, Rachel. Just check, can you hear me?
Yes.
Thank you. Yeah, good morning, good afternoon, everyone. Thank you for taking time to join this webinar today. In our webinar today, I'm going to show you how TDW contributed to repair of a critical gas transmission pipeline without having to bleed down the entire pipeline. The title of our webinar is Advanced Pipeline Isolation Solution to Enhance Valve Changeouts, Minimizing Downtime, which is a case study for a project that TDW conducted in last year during Chinese New Year for China Petroleum Corporation, which I will just refer to as CPC. Depressurizing or bleeding off large gas transmission pipeline for repair or maintenance is feasible, but often expensive, with costs related to flaring of a large volume of gas and prolonged supply interruptions. This is where pipeline pressure isolation of short section becomes a very attractive alternative to removal of the hydrocarbon content in the entire pipeline. CPC is the sole natural gas supplier to Taiwan. To stabilize the supply of gas for the domestic market, CPC has established an integrated ring-shaped gas distribution network in the western part of the island nation. It includes an inline transmission trunk line, offshore transmission trunk line, and regional transmission loops. The 36-inch diameter Yong'an to Tongxiao offshore pipeline, shown at the map here, is the largest and the longest transmission pipeline in the entire network, delivering gas from the southern Taiwan to the domestic or the dominant gas market in the northern Taiwan. It connects the Yong'an LNG import terminal and Tongxiao transfer station 238 kilometers apart. Normal operating pressure is 70 bar. CPC needed to perform repairs at both facilities. By isolating the work zone, CPC avoided depressurization and purging of the entire gas export line and kept more than 280 million standard cubic feet of processed natural gas from being flared off or vented, preventing a huge business opportunity loss and event of significant environmental impact. What is more, it would have taken several days to fully depressurize and flare off the entire pipeline and several more days to reintroduce hydrocarbon into the pipeline before gas deliveries could resume normal. Sometimes the project schedule did not allow for. In fact, the work had to be completed in just 7 days during the 2019 Chinese New Year holidays, when energy consumption in Taiwan is lower than usual. So what was the issue that needed to be rectified? It was discovered that the emergency shutdown valve, ESDV, at both the Yong'an LNG terminal and the Tongxiao gas transfer station, seen at the picture here, connected by the pipeline, require maintenance and replacement respectively. The ESDV and valves on the production T at the Yong'an required replacement of the seal rings on the valve flanges. At the Tongxiao, the ESDV, which is the valve immediately after the receiver shown at the picture here, had to be completely replaced, and a corroded branch line needed to be removed from the pipeline. Continued operation with defective pipeline isolation valves would have been highly undesirable and would have caused many safety concerns for the pipeline owner. Using pipeline isolation technology allowed the operator to avoid depressurizing and purge the entire gas transmission pipeline. The valve maintenance work was required so that CPC could resume operational pigging as well as carry out regular inline inspection. So, testing of leading down large gas transmission pipelines for repair or maintenance is feasible but very expensive. The CPC project used 2 economical and safe alternatives for isolating and bleeding off a short section of the pressurized pipeline. The first method is online isolation, also known as hot tap and stopple. It is an intrusive isolation technique shown on the picture to the left, where the permanent fixture or fitting is left on the pipeline. The second method is inline isolation, also known as piggable isolation or smart plug. It's a non-intrusive technique shown at the picture to the right, and no permanent fixture are left on the pipeline. Both isolation method can be used as the main isolation, but in this case, CPC did not want to leave a hot tap fitting on the pipeline and choose to go with smart plug inline isolation technology to create a safe work zone at each site. Smart plug isolation has been used many times in Southeast Asia over the last 2 decades. It was the first time it had been deployed to Northeast Asia, including Taiwan. However, there was one issue. Since the emergency shutdown valve, the ESDV on the Tongxiao was leaking, so the pig trap was pressurized. So the quick opening closure could not be opened safely, and we had to use both technologies. So before we could even load the smart plug into the pig trap, a hot tap and stopper had to be used for temporarily isolate the receiver from the leaking emergency shutdown valve, ESDV. We will come back to the details of the execution, but first we want to look at both of these isolation methods. So smart plug inline isolation. Inline isolation involves pigging of the smart plug to the desired position and establishing an isolation there. Existing pig trap quick open and closure are used at the pipeline as the pipeline entry and exit points. The isolation tool is introduced into the pipeline in the same way as a pig or inline isolation tool. It is launched into the line under pressure. Project requirements will determine whether it's propelled to the isolation point using pipeline product, but this is provided the pipeline has flow and that you pig in the direction of the flow. Another way to propel the smart plug is to use external set of pumps or compressor using either treated water or nitrogen as pigging medium. In this case, the pipeline remained pressurized, but the flow was not shut in, so we had to use external nitrogen pump to pig the smart plug in position at both ends. In any case, pigging from the receiving end of the pipeline, external pumps have to be used. Smart plug tool is bidirectional, which means it can be traveled in both directions. Depending on the pipeline system, after isolation, it can generally be pigged to the opposite end, provided as flow that is in the flow direction, or back to the point of entry after the isolation has been completed. However, since most isolation are happening close to the pig trap, the most common is to retrieve the tool back to the pig trap it was launched from. The smart plug is remotely controlled via through wall communication, as you will see from the two next slides with animations, and its position is tracked as it travels through the pipeline. Different from online isolation, inline isolation tools do not require the installation of external fitting on the pipeline. Bleeding off of any leak product between the two barriers is not necessary, as it would be in a double block and bleed isolation. Smart plug tool represents a true double block and monitor DBM isolation. Retaining and monitoring the annulus pressure between the two plugging modules to ensure the integrity of the isolation. The smart plug isolation tool is a type approved by DNV and complies with the offshore codes and recommended practice, such as DNV RP113 recommended practice for pipeline subsea repair and DNV OSF101 offshore standard submarine pipeline system. This is an animation, so I try to speak a little bit slow so the animation can catch up. The smart plug tool is remotely activated and uses internal hydraulics to engage the gripping elements and slips and the sealing elements, the packer, which is the red thing that you see on the animation here on the pipe wall. Yeah, I pause a little bit there. So once the gripping and sealing elements are fully in place and engaged on the first plug module, the downstream pressure is reduced to approximately 50%, creating a differential pressure across the first plug module. This is then repeated for the second plug modules in sequence. Before we bleed off the pressure to zero. This plug module is a fail-safe lock design, and differential pressure across each plug module is used to maintain the fail-safe isolation. By fail-safe, we mean that any increase in pressure across the plug module will increase the tool's gripping and sealing ability even further. It also means it cannot be unset until you have equalized the pressure across the plug module, which is an important safety feature for this kind of isolation system. The Smart Plug tool provides full double block isolation using 200% independent isolation plug modules. Each plug module is capable of isolating the full pressure of the pipeline, giving the other 100% contingency. Once the Smart Plug tool has been set, we will monitor the annulus pressure between the two plugging modules for about 4 hours to ensure that we have a good seal on both plug modules before we issue the isolation certificate and the construction activities can commence. The annulus pressure will be continued to be monitored to ensure that the integrity of the isolation is maintained for the duration of the isolation. Yeah, I have another animation here showing a bit about the communication system and the tracking. The Smart Plug tool is remotely activated, monitored and tracked to the set location using true wall communication via Smart Track system shown on the animation. The communication system uses extremely low frequency ELF signals, typically less than 15 Hz, which can travel through thick wall and even coated and buried pipelines. We are able to track the tool, so you see the figure to the right, from it leaves the pig trap until the set location, which in Taiwan case was only a few meters. However, in other cases, pigging might be many kilometers or even hundreds of kilometers. The pigging is stopped at the set location before we start the setting sequence, as you saw on the previous animation. This system allows us to send commands to activate the tool and to monitor it once the Smart Plug tool has been set. There's a built-in redundancy to be able to unset the tool even in the unlikely event of loss of communication by use of an onboard mechanical fail-safe system called dump valve. Okay, I'm now going to talk about the other technique, which is hot tap and stopple online isolation. For online or intrusive isolation, is where you have a stopper that is inserted through the pipe through a hot tap fitting that is purpose-built for the pipeline. The hot tap fitting, also referred to as a split T, is welded onto the pipeline at the required location. In this case, the minor barrel. Hot tap fittings undergo extensive engineering and validation testing and are designed to meet the code requirements for piping system on which they are installed. Because the welded fitting remains as a permanent item on the pipeline after the hot tap and stopple operation, it undergoes full non-destructive examination to ensure its integrity as an integral part of the pipeline. First, the sandwich valve and the hot tap machine are bolted onto the fitting on the pipeline, and a full leak test of the assembly is carried out prior to work commencing. This ensures there is no product leak after the drill passes through the pipeline wall. The pressure retaining hot tap machine drills a hole in the pipeline through the fitting using a special cutter or hole saw. The cut-out coupon is then retained. Next, the stopper system is inserted through the fitting to isolate the pipeline as shown in the figure to the left. And once the isolation has been completed, the stopper can then be removed. Going to talk a little bit about the project timeline. The work in Taiwan had to be executed only in 7 days period during the 2019 Chinese New Year holidays, when the energy consumption in Taiwan was lower than usual. The CPC commenced bidding activities for contractors in August 2018, and CPC awarded the contract to Yunhui Mechanical Engineering, a local contractor in Taiwan, and TDW. TDW assembled a 236-inch Smart Plug isolation tool and completed factory acceptance testing FIT at this Stavanger, Norway Global Solution Center. TDW also manufactured hot tap fitting at this manufacturing center in India, and assembled hot tap and stopple equipment at its original solution center in Singapore. The complete set of combined isolation equipment was shipped from Norway, India, and Singapore to Taiwan. Yonghui mobilized to Tung Chau site in the third week of January and welded a hot tap fitting onto the minor barrel of the receiver. The TDV crew mobilized to the two work sites at the end of January 2019. The smart plug was launched and set at Yunnan on 3rd of February and Tung Chau on 5th of February. Yonghui Mechanical Engineering completed repair and replacement of isolation valves before the smart plugs were unset and retrieved at Yong'an on 8th of February and Tung Chau on 9th of February. Delivery of gas resumed successfully on schedule on 10th of February. Smart plug engineering. One critical concern about inline isolation is to check the piggability of the smart plug in the line. That is to ensure that we can pick to the set location and come back out again without getting stuck. It is critical that we have reliable pipeline information and we perform 3D modeling of each critical pipeline component, such as pig trap, production T, valve, and bends, etc., to check that there is no interference with the smart plug tool. Another of the critical concerns is the potential of excessive pipeline hoop stress. This is hoop stress approaching the elastic limit of the pipeline at the location of the slips and the packer of the plug modules. From these stress finite element analysis plot shown in the figure here. Excessive hoop stress can occur during either the initial setting or during the isolation period. However, spreading the stresses over both the isolation tool plug modules, each which has been assessed individually against full potential pipeline pressure, helps ensure that the hoop stress does not approach the elastic limit of the pipe and further enhance safety during the operation. So back to the operation. Because the ESDV at the Tung Chau site was leaking, TDV could not safely open the receiver of the quick open enclosure to load the smart plug tool into the receiver major barrel, without first doing a hot tapping on the line, performing a stopple operation. With the stopple in place, we could keep the receiver barrel gas-free and loading the smart plug tool could be done safely. This hot tapping operation started with that we welded our hot tap fitting onto the minor barrel of the receiver, which is the red item that you can see on the picture here. And after the welding, we did non-destructive testing. So once the fitting had been welded and tested, the hot tap operation could take place under full pipeline pressure. As you saw at one of the previous slides, hot tap machine drills a hole in the pipeline through the fitting using a special cutter or hole saw. Next, the stopple system is inserted through the fitting to isolate the pipeline, as shown at the figure to the right, so that the major barrel of the receiver could be made gas-free. So next was to load the smart plug into the receiver. After ensuring that the receiver was free of hydrocarbons, the smart plug was loaded into the major barrel and pushed close to the stopple seen on the picture to the left. The quick open enclosure could then be closed and the stopple tool retrieved so that we were ready to launch the smart plug tool. At the Yong'an end, at the launching end, the ESDV was not leaking internally, and as a result, the smart plug tool could be loaded in the conventional way without the need for temporary isolation. The rest of the steps that you see in the presentation is applicable also to the smart plug operation at the Yong'an launching end. Following loading of the smart plug tool into the major barrel of the pig launcher and receiver, the smart plugs at both Yunnan and Tungshao sites could be pigged to the set location using nitrogen pumping services provided by a third party. Although there were some pigging issues in launching the smart plug at the Tungshao site, these were overcome and each tool was launched and set successfully. On the pictures, you see the smart plug tool leaving the pig trap when negotiating the ESDV and the production T up to the set location. So the smart plug tool was set in the predetermined location in the pipeline, and a safe isolation was established against the shut-in pressure of approximately 58 bar or 840 psi. After setting the isolation tool, the annulus pressure between the two plug modules were monitored for 4 hours to verify that both plug modules were sealing properly. Once this was verified, an isolation certificate was issued to the client. Following the successful isolation of the two ends of the pipeline, valve replacement work at the Tungshao site and valve maintenance work at Yunnan could commence. So now to unsetting and retrieval. Upon completion of the repair work, the launcher and the receiver end of the pipeline were pressurized with nitrogen as a part of the unsetting procedure. Before unsetting 2 smart plug units, the team conducted a pressure leak test to verify that all flange joints were leak-proof. After the leak test was successfully completed and integrity verified, CPC has satisfied that the valves have been repaired and signaling the successful completion of the operation. With the pressure differential across the smart plug tool equalized, plug modules were unset and the tool was pigged back to the launcher and receiver using the gas pressure from the pipeline and bleeding off the nitrogen pressure from the pig trap. A normal operation could then resume. After the maintenance work had been completed, the sandwich and tapping valve was recovered by installing a locker ring plus plug into the flange of the fitting shown in the picture to the left. Normally the fitting is and will remain on the pipeline, becoming an integral part of the system. The fitting itself can then be re-entered for future isolation operation if the need arises. However, in this case, with the ESDV rectified, the fitting was later cut out from the receiver major barrel. Okay, so some conclusions. The pipeline isolation with the smart plug and hot tap and stopper was one of the major drivers for the February 2019 shutdown campaign. The smart plug system offered a quick and reliable alternative to otherwise unsafe, costly, and time-consuming options. The 36-inch offshore pipeline from from Yunnan to Tungshao accounts for a considerable share of Taiwan's gas supply. For this reason, it was critical that the shutdown period to be kept to a minimum and the isolation of the pipeline be accomplished without delay or complications. Smart plug technology allowed the operator to avoid depressurization and purging the entire gas transmission pipeline, which prevented the flaring of more than 280 million scuffs of natural gas. It also reduced the project timetable, and repair and replacement of the ESDV were completed as planned within the allowed shutdown time. With integrity of the pipeline restored, CPC resumed normal production safely and fully functional ESDV and sound pipeline components. Thanks to comprehensive engineering studies, technical reviews, good planning, and the contribution and high safety awareness of all relevant personnel, the valve repair and replacement and the smart plug operation were conducted in a timely and safe manner without recorded lost time incidents or unsafe conditions. Yeah, I just want to show you some acknowledgement. There was a lot of people that contributed to making this is a success. I'm not going to read the names. You see them on the slide. I also just want to mention that during the execution of the project, I had the opportunity to go and visit both sites, and it was very exciting to see this thing happening. It drew a lot of attention from many people in Taiwan, as this is the first time they've done smart plug isolation there, and everybody was very happy when we executed this successfully. So with that, I believe that's my last slide, and I believe we're going to have some Q&A, so I'm going to hand it back to Rachel. Rachel, back to you.
Thank you, Rolf. Yes, indeed, there are a number of questions. So the first question came from Donnie from Patavina. His question is, until how many mm thickness of concrete weight coating which transmitter installed at external pipe can be detected by smart plug pick? Or we have to remove CWC first prior to install transmitter?
Yeah, so coated pipelines, to communicate with through coated pipelines is not an issue, even in very thick concrete coating. So, for example, subsea pipelines have very thick concrete coating, and they are sometimes even buried, and we are able to communicate through that.
Okay, the next question is from Michael Octavian. How about implementation of subsea pipeline? Regarding the ability of communication smart track system, and how deep is the depth of the communication that can reach?
Yeah, Gary, would you like to have a go at that one?
Yeah, I can do that. Yeah, the communication system that was shown in the presentation, which was onshore, where there was a unit which sat on top of the pipeline, and then it was wire connected back to a laptop. That is no different for subsea. We would use a subsea skid unit which goes down onto the pipe itself. The depth will be pressure related of the unit itself. So we have tested systems down to about 2,200 meters. So we know we can go down to them sort of depths. And then we can either hardwire it back to the surface using a cable, or we can use acoustics to actually radio communicate back to the surface as well. And that gives us a longer range. So we would view it project by project, but that's typically the way we would do it. So water depth should not be an issue for communication.
Thank you, Gary. One question was posed by Mr. Vignesh PV. He is referring to online isolation, whether all the valve replacement will require hot tapping, that is online isolation stopper method.
Yeah, I'm not sure if I understood that question correct, but you could use hot tap and stopper as isolation method in the same way you used smart plug, if that was the question from the gentleman.
Okay, the next question is, do dust, mud, rust, or wrapping material affect the performance of tracking system? What is the error limit? This question was posed by Mr. Shah Alam.
Again, I can answer that. The wrap is no different to the concrete coating in the sense that the smart track system that we use, because of the extremely low frequency that its technology involves, coating should not affect the performance. with the tool itself or the system is designed to actually communicate through 65mm wall thickness. So a wrap on the outside should not present any issues when we're using for smart plug.
Mr. Muhammad Zaman raised a question: how leaking problem of ESDV was solved?
Yeah, so in this particular case, basically they replaced ESDV at the Tongshow, the receiving end. So they replaced the whole valve with a new valve. In the young end, they overhauled the valve. Basically, they opened the valve, they replaced some seal rings, and they also replaced some seal rings on the flanges.
Okay, thank you, Rolf. Mr. Vignesh PV asked another question: what is the operating pressure of the pipeline? And during the hot tapping, how pressure was maintained? Yeah, so in this particular case, the shut-in pressure, which is the pressure when it stops the flow in the pipeline, was 58 bar. So that was the pressure that we had, and when we did the hot tapping operation, the pig trap was pressurized also to 58 bar. So that was a stable pressure along the entire 238 kilometer pipeline. So that kept the pressure stable. Okay, another question from Mr. Shah Alam again. If I have launching point 50 to 100 kilometer away, then should we take preparation like pigging operation? Gary, you wanna?
Yeah, could you repeat that question, please, Rachel? Sorry.
If I have launching point 50 to 100 kilometers away, then should we take preparation like pigging operation?
Yeah, to the pigging operation prior to a smart plug operation, obviously you would need to have the pipeline cleaned. So that would be a standard routine pigging, which may need to be stepped up, very similar to what you would do for an inline inspection program. For pigging distance, the smart plug is effectively a bidirectional pig, so we shouldn't have any issue pigging its distances. We have tested the system to pig for 1,200 kilometers, and we have actually ran the system in excess of 350 kilometers. So that in itself is not an issue, and it just becomes a routine pigging operation and preparation of the pipeline for cleanliness, as you would do with an inline inspection program.
I can maybe just add a little bit to that. And we mentioned the piggability study that we did in this case. When you pig a long distance, piggability study obviously becomes even more important. So we need to know the bends and the restrictions that you have in the pipeline, and then we will just do the piggability section for the entire line that we're going to pig. Mr. Bipul Chandra Das asked this question: what is the effect of gas velocity inside the pipeline? So the effect is, so during pigging, you need to know what the velocity is. So if you're pigging long distance, you want to make sure that you don't pig too fast, because obviously smart plug is a massive piece of tool, weighing 36-inch can maybe weigh as much as 5,000 kilos. So you try to limit the pigging speed to about 2 meters per second or around that. However, in very often pipelines are shut in but not depressurized during pigging, and you only pig a very short distance, which also was the case in this instance. And their speed doesn't really matter because you use pigging pumps, and that goes relatively slow anyway. Okay, the next question is from David Levy. Can you run 2 smart pigs in series to isolate upstream and downstream of a repair feature?
Yes, you can. There's no straight answer to that. What has to be assessed is what that feature is, because you will pig both smart plugs from the same direction typically. So one smart plug will have to pass the feature. But once that has passed and you then have two smart plugs either side of the feature in question, you can actually isolate that and then depressurize the section in between and remove or repair that feature. And we've done that on a number of occasions, including subsea, where we removed a subsea feature.
From Mr. Fazlal Karim, between the two types of isolation system, which is better?
That all depends on the application. We cannot say that one is better than the other, and it depends really on the application that you have. So if you have, for example, a line that has never been picked before, and you know it well, you know the restriction in the line, you don't have a choice. You have to use hot up and stop bulb, because we using smart plug, let's assume that the line is pickable. If you have dealing with a long gas export pipeline like you saw in this case, people tend to prefer inline isolation for a number of reasons. It's generally easier. You don't have to weld a fitting on the line. So really it all depends, and we very often offer both, and that was also the case early on in this project. We offer both methodologies, and we let the customer choose which one they wanted.
Mr. Raziullah asks, can smart plug be used as permanent isolation, as we don't have provision for pigging?
In theory, a smart plug could become a permanent feature, because once it's set in place, it uses the pressure of the pipeline or the differential pressure across it to hold it in place. Practically and economically, it's probably not the best method. And you mentioned that you would have difficulty or piggability as a challenge. Then obviously you do need to pig the tool into place. So that in itself is something that would need to be overcome. From a timeline perspective, we have had smart plugs in position for approximately 14 months, and we are actually currently on a project where the intention is to have a smart plug in situ for 2.5 years. That's in a subsea tie-in project, but generally speaking, it's not being considered as a permanent feature, but in some ways there's no reason why it shouldn't be if it come to that.
The next question is from Mr. Kamrul Islam. How the chips are collected from the pipe when drilling in online system?
Yeah, for hot tapping, you cannot avoid that some of the chip will actually fall into the pipeline. That cannot be avoided. The coupon will be retrieved, but the chip from the cutting, they will fall into the pipeline.
Mr. Arif Laksana has a question. Was the smart plug applicable for flexible pipes with carcass material inner side?
I can answer that. It's to date we have not isolated in flexible pipe. It has been considered in the past, and we are currently in early stages of discussion with flexible pipe manufacturer because of the improvements in the stress capabilities of flexible pipes, to see whether it is a feasible option. But to date, we have not done that yet.
Just to add to that, it's been considered to set in the termination fittings of flexible pipe. So I remember one project in Brazil where they had every so many kilometers they had like a fitting. So we considered setting in the fitting, but that never happened. So.
Mr. Rahul Shah would like you to throw some light on annulus pressure.
Yeah, so like you saw in the animation, and the annulus pressure is the pressure that we have between the two plug modules. So our system is a double block-in monitor, so we keep a pressure of typically 50% of the isolation pressure in the annulus. And the two reasons for that. Number one is that we want to have differential pressure across each plug module. So the first plug module, you're sitting with about 50% differential pressure, and you also have 50% differential pressure across the second module. That ensures the best reliability number because you have both the plug modules sitting in self-lock. Now, that the annulus pressure is also very valuable for monitoring because we can monitor that for the duration of the isolation. So any indication or in the unlikely event that that pressure was increasing, we know that that must be the plug from the high pressure side that is leaking. If that pressure was decreasing, then it must be the plug on the low pressure side that is leaking. And that is also why we have this 4-hour holding period before we issue the isolation certificate. Only if that annulus pressure is stable can we issue the isolation certificate, and then we know that both plug modules are sealing 100%.
The next question was from Mr. Zubri Rahman. What is the smallest and largest size for TDW smart plugs?
Okay, the official range that we cover is 8-inch through to 48-inch diameter. But reality is that the 8-inch was a bit of a special, so it's not typically being used elsewhere in other pipelines. So 10-inch through to 42-inch is the tools that we've actually used, but we do have 48-inch tools which have been developed and tested, but they've never been used in a 48-inch pipeline.
The next question is from Mr. Herden Everstein. The inline isolation was worked successfully with gas services pipeline. How about, or is it workable as well with a crude oil services pipeline? Considering wax materials on the inside pipeline surface for an old pipeline, which may possibly occur.
Yeah, thanks. That's a good question, and the short answer to that is yes. You can isolate crude oil lines as well, and it's been done many times before. Although I would say probably 75% of all isolation take place in gas lines. The rest is in crude oil lines, and it's a good point. If you have waxy crude oil lines, you have to clean the lines first. So you have to run some kind of cleaning program to make sure that you have a reasonable clean pipeline before you send in the isolation tube.
The next question is from Mr. Muhammad Tanwar Hussain. What are the most critical parts in this operation?
I think for the operation which was shown in the case study there, the critical part was the upfront engineering, because the assessment of how we were going to do it, and that was, you know, the initial assessment of what isolation method we were going to use, and in this case where we had to combine isolation methods, and all of the engineering work that was done up front, because we had a very, very tight window to actually carry out the operation. So we needed to ensure that, you know, every angle had been covered long before we actually got to site. And that was reflected in what went on site, which was a relatively smooth operation, and certainly within the time constraints of the shutdown.
Mr. Desikan NV has two questions. First, is there any system to monitor the integrity of smart plug? And number two, whether this smart plug can be used in between two different plugs.
Yeah, so the answer to the first question is, like I mentioned, with the annulus pressure. So that pressure is being constantly monitored. So we call up the tool every hour or so to read that annulus pressure. So yes, we do monitor, or we do read that pressure and monitor the isolation for the duration. And that can be in days, like you saw in this case. In some cases, we have plugs sitting in the line for weeks and months, and even years. If you do isolation for years, obviously the frequency of the monitoring becomes a lot less. but it's still being monitored. Sorry, what was the second part of the question?
Whether the smart plug can be used in between two different plugs.
Yeah, I guess if I understand correctly, if you mean you can use two smart plugs, the answer is yes. So if you do a midline cutout, you will then pick two tools in. You launch one tool, then a slug of water or glycol or something like that. The second tool, and you will pick the whole thing to the location, set the tools, and you can then perform the cutout. If I understood your question correctly.
Yeah, and just to add on to that, the smart plug is an isolation tool which can be used independently, or it can be used in combination with other methods. So whichever method will suit the project, smart plug can become part of that, as can a stopple as well. So combining the two, or used separately or in conjunction with other methods of isolation, such as an inline valve, which is still working, these can all be used in the engineering creation of the project.
Mr. Anmar Kadam, he asked this question. It seems space is required approximately 4 to 6 meters for hot tapping, 16-inch NB and above. Is there any alternate option available for onshore pipeline where there is space constraint? Can you please show actual picture for similar issues?
Okay. When you say 4 to 6 meters for hot tapping on a 16-inch line and above, the space requirement on the pipeline is not typically, it's probably about 2.5 times the diameter or twice the diameter of the pipeline for the fitting itself in length. And that is really dictated by pipeline codes as to what the requirement of that fitting would be. So alternatives, smart plug is an alternative, but again, you don't need any external space or space requirement on the pipeline, but you do need an internal stretch of pipeline to allow the tool to actually sit. So again, going back to the previous question, the solution would be engineered for the best requirements of the project itself. I hope that answers the question.
Okay, the next question is from Mr. Bright. I hope I pronounced your name correctly. Bench Singh. Have you faced leaking of smart plug anywhere in the world? How do you make sure sealing is at 100% before you release the construction activity?
Yeah, so the answer to that is yes. We have cases where we have launched and picked the smart plug to the set location, and we then set the tool, and we cannot get a stable annulus pressure, which is the criteria to issue the isolation certificate. So the mitigation for that is normally to unset the tool, maybe move it a little bit, a couple of meters, and then set the tool again. If you are unfortunate and set in a, for example, a heavily corroded area, that can sometimes, it's not very often it happens, but it can cause a problem or cause a leak on the smart plug. So usually when you move the tool and you set it again, you get a good seal on the second attempt. But it's used. I mean, the first time success rate or the first time setting success rate is quite high.
This leads to the other question, which is similar. What is the fallback plan if the stress due to stopple leads to deformation in pipeline diameter beyond the limit?
Certainly in both cases, this is typically done as upfront engineering. So the expectation is that we would not overstress the pipeline. We would not go into a pipeline if there was any chance that we would overstress it. And we can do that. We would do that calculation long before we got to site.
And just to add to that, it's also possible to reinforce the pipeline. So for some onshore, it's not usually an issue on offshore pipelines, but onshore pipelines can be quite thin wall. So it's possible to put a reinforcement clamp in the set location in case the pipe stress calculation come out too high.
Okay, there's one question regarding speed T welding by Mr. Jerish Muller. Dear sir, during speed T welding, how was the velocity maintained inside the pipeline?
Yeah, that's a good question, and the answer is that there was no velocity. So this was a non-flow condition. So we need to do special calculation on heat transfer for welding cases like this. Normally you will weld a fitting somewhere midline, and you will have before you shut down the production, so you will have a flow. But in this case, it was a stagnant flow, but it's possible also to weld a fitting under stagnant flow condition.
We have only 1 minute left, and we're only halfway through the questions list. So I'm going to pose one last question, and this is from Mr. Amir Hossein. How much time by percentage does smart plug save over traditional valve changeout?
I mean, the time saved is really, if the alternative for using smart plug or another isolation method is that you will have to take out the hydrocarbons from the pipeline. And in the example we shown, that was 200 plus kilometers of high pressure gas pipeline, which would have to be evacuated. It would have to be purged in some form. And so the simple way of working that out is how long does it take to depressurize such a pipeline? It's quite a significant time period. You've then got to bring the whole pipeline back up again, which is virtually a new commissioning of the pipeline and bringing it on stream. So when you add that whole time span in place, and during that whole time span, the pipeline is down, as opposed to pigging a smart plug in position and setting it, which is all done in a shift. And then obviously work can commence at that stage, and the whole thing is unset and recovered in a shift as well. So it really depends on the pipeline, but it's very easy to work out depending on which pipeline you're looking at. But significant time series.
Okay, thank you, Gary and Rolf. Okay, we are now at 2:01. So, dear participants, we are sorry that we are unable to answer all your questions. And thank you very much for your questions, which are overwhelming, which is very good to begin with. So, Rolf, can you share your last slide? Okay, for questions that we are unable to answer during the webinar, please post them in the survey, which will be sent out after the webinar. Alternatively, you may also contact the sales manager from TDW who are in charge of your territories, and we will be certain to address your questions accordingly. Thank you very much and have a good day.